I don't have visuals, and it's really just going to be a little intro to the device that the device that I put together. So
Nice.
feel free to go ahead and introduce me right now.
Yep. Yep. All right. Well, Gale, actually, world, this is Gale. Gale has a wonderful presentation she is going to give to us. And whenever you are ready, go ahead and kick it off. I'd love for the audience to know before you start, maybe just a quick bit about yourself. What you're doing, and then obviously the beautiful presentation you prepared for us.
So, hi, I am Gale, and previously I actually was the manager for the Nomad team, so at HashiCorp. So I have been poking around and doing interesting Nomad things for a while. And that's my background includes doing all sorts of systemsy things before that, primarily as more on the operator side and as a just DevOpsy stuff. So normally I spend more time wrangling Terraform than Nomad per se, but this is I've been immersed in Nomad for quite a bit now. So
Very nice. Thank you for that. And today you will be showing us what in a nutshell?
So today I will be talking about the PiDP-11. And so originally, one of the things that, let me just sort of give an introduction to this machine. So the PiDP-11, which is this thing behind me over there, with the lights that should be blinking, but are not blinking at the moment. That is, so that is a reproduction of a PiDP-11. So as you can see, it has, it's just going to go ahead and walk back here a little bit, okay?
Perfect.
Whee! So, and its friend right there, its friend is an Altair 8800, which looks cool, but we won't be dealing with that. It's again a repro of just a historical computer. So the PiDP-11 here, which I will just show you, is a I forget, it's a scale model of a PiDP-11, and one of the reasons why it's so interesting is because basically it has a unique place in history to anyone who has touched with or worked with Unix, or just for a variety of reasons. It was a monumental, just a monumental machine, and so it was the computer on which Unix was developed, and
okay.
because of the machine's popularity, the PiDP-11 is really what allowed Unix to be distributed worldwide. And so, not everybody ran Unix on it. It ran a variety of different operating systems, but it became the machine on which to run Unix. And yeah,
why
so
is that?
So that's a good question. So it was powerful enough. It was small enough as a mini computer. There were free, or basically you could get distributions for it, and so the net result of this was you had a thriving operating system, you had this thriving environment, and this thriving culture. So there are a couple of let's see. So that's really, I mean, that's really the part of the reason that I wanted to build this. I had
Yeah.
heard folks speaking in this reverent tones about the machine, and just really wanted to kind of get a glimpse of that. The other thing that's interesting today about the PiDP-11 as a platform is that it runs unices that are familiar enough to feel modern when you use them. So basically most other mini computers, most mini computers of that era, just whatever they're running is fairly foreign and unfamiliar to us. But this machine will actually run, so it'll run things that feel very, very System 5-y. It will run I think BSD 2.2, which has the just when you look at when you're in commands, when you look at the user land, it feels like a Unix.
Interesting.
So what this unit is actually, even though it looks like a tiny little PiDP-11, it is powered by a Raspberry Pi.
Nice.
Yes. So we have effectively what we have here is a host machine that is a fairly capable machine. It will do anything a Raspberry Pi will do, but
Nice.
it will also, as a guest, it can run. As a guest, it can run lots of. It's running an emulator, and the emulator is what is. The emulator is what's running. It's running an emulator called SimH, or I think it's how it's pronounced. And that emulator is what will allow us to work with OSs on it, among other architectures. It emulates. Well, right now we have it emulating PiDP-11. So
yeah, of course.
Yeah. And originally, what I was hoping to do was to actually, given that BSD, given how modern or modern feeling the BSD that runs on it is, I was hoping to get to actually be able to get a Nomad client on it.
Nice.
So it turns out, yes, that would have been nice. And as cool as the thought of running Nomad on a PiDP-11 is, it's not really feasible. Nomad is a modern application. It's written in Go. Go hasn't been ported to that architecture as far as I know. And it would be very, very hobbled by the address space limitation. So a program can't be larger than, I think, 64K 64K code on a PP11. So the various operating systems for it, I don't think anything has pthread support or any threading at all for that matter. So, but what we can do is run a Nomad client on the Nomad agent on the host box. And we can, in fact, control the rest of the unit that way, in much the same way as you would control any sort of small form factor computer with a peripheral attached. And so, as silly as this is, the interesting applications or the applicability to real life is being able to run, run things that have specialized, that attach to specialized devices using Nomad. So Nomad, given that it is lightweight, is really a pretty nifty fit for that. So nice. Just go ahead and try to get this running here.
Yeah, sure.
Live demos, aren't they awesome? So
of course. You know, technology aside, that is a nice added decoration to the room as well.
It is pretty cool. So I'm actually gonna bounce this guy because I think I got him stuck. And actually, so right there, can you can folks see? So what you're going to see in a couple of moments, hopefully, is that that panel of blinking lights should come alive.
Nice. Lights are good.
And here, let me go see what it's doing.
Oh, there they are.
Yep.
It
So that is currently running, basically running an identification program. So it's running something that just sort of runs the pattern on the LEDs. It's the same thing that when I soldered it together. So this came as a kit,
Nice.
and it's actually a kit that you can build. If I could solder it together, anybody can solder it together. And yeah, so in addition to looking cool and having having the so the switches actually work. They do what they're supposed to on a PiDP-11. So in addition to that, it can also do anything a Pi can do, such as being a running the Nomad agent, or running RetroPi, or just what have you. So yes, it is a pretty cool thing to have hanging around your office. And let's see. I wanted to go ahead and control it from here, which I'm going to try to do. So happy to answer questions about it in the meantime. There were a couple of things also that I wanted to point out about it, just in terms of in terms of what having why would somebody do this, apart from the blinking lights are cool. Just sort of what is the historical value, and what is the value to us today of having something like this. So if you just give me a couple of seconds, I'm happy to chat about it in the meantime, but just want to get some stuff orchestrated here.
Yeah, absolutely. That you're like, anyone can build that. I'm not a hardware person in the sense that I like it. It just doesn't like me.
That's what I've heard before from software folks. And this is, so I hadn't done hardware stuff in a really long time. Okay. And really, if you can get the sort of the Elenco AM radio kit and kind of put that together without seriously burning yourself, you can do this. So it's nice. I want to stress it is pretty easy to put together. Let me go ahead and apologize. I had Nomad and everything in my job ready to run here, and nice. Because I decided to live dangerously and do a live demo, it's not there. So
take your time. It's all good.
All right. Cool. Let's see. So again, I just try to get the one of the OSs going, but sadly, in terms of technology, getting Nomad to actually run on a guest was just it was just not a thing. But again, going back to the fact that there's a Raspberry Pi in it, and it's a fake PiDP-11. It's a PiDP-11. We can do anything that the host machine can do, including just so by talking with the host machine, we can control the emulator, we can control the, we can communicate with the guest OSs and so forth. We can talk to a serial device that might be on it, so forth.
Interesting. So while you're doing that, I do have a question, because, obviously technology moves fast. It's very easy to overlook the history. Obviously, this was not the case here. I'm just curious, and I'm sure other people are as well, aside from the clout that such a machine had in the past, at what point where you're like, I'm going to build that, and why?
So First, again, I've always wanted one, except they're large, and they are at this point expensive if they still work. So if you can find them, if you can get them in a space, if you can restore them, if you have the if you have 220-volt power to deal with them, it's yeah, it's still a lot of work, and so I always kind of wanted to do that. But when I found this, first of all, it's adorable because it's a scale model, and one of the rules of cute is that
Yeah.
a thing, and then if there's a thing and there's a smaller thing that's like that thing, the smaller thing is cute. So
Yeah, exactly.
uh, so that was part of it. But really, one of the so my talk at HashiConf EU this just a couple of months
Yeah, just
ago
recently.
was about Nomad as a green orchestrator. So since Nomad is lightweight, and since it's just it there are a lot of interesting things in and around Nomad that lend itself to being a being a lightweight and being an efficient orchestrator.
Mhm.
So the kind of one of the things, again, I think that's important is just remembering our history. And in these
Mhm.
times, it's a very useful reminder to realize that our current compute resources are essentially infinite compared to what existed just a few decades ago. And so the PiDP-11 was just this monumental machine in its time, and yet it has no chance of running anything modern. It has limited address space, limited number of CPUs, limited physical resources, and those are constraints that we barely have to think about today, even on mobile device platforms and even at the edge.
True.
So that's just understanding what we can do with what we can and cannot do with something that is far more constrained than anything somebody's going to have in their pocket today is just I think it's valuable as developers. It's valuable as technologists for us to bear that in mind. So
Yeah, that makes perfect sense. So it sounds like beyond history, it was also a good exploration of working within constraints, and as you said, a reminder of the constraints we don't really face as much now, since your phone can just do so much, it has so much compute. So my question for you here: what do we have left on the agenda you wanted to show us with the PiDP? Just in terms of time, we do have another speaker coming on. This is
I
so
know.
amazing. Yeah.
So what I was hoping to show you was running a raw exec job and actually running something on one of the one of the guest OSs, which
Yep.
is unfortunately not cooperating. Again, this is what happens when you live
Yep, it's
dangerously.
live.
So
Yeah.
yeah, what I would like to do is actually point folks towards, just give me a second and I will
Yep.
grab it. Wanted to point folks towards this particular project, and there are two things that you can do even if you don't have this, even if you don't have the physical hardware. First, you can run the simulator. And so
Okay.
you can experiment in the privacy of your own VM, privacy of your own preferred setup, with running the simulator, running different things under this hardware simulator.
Nice.
And there's also let me just grab this again. I had it up there.
Sounds good.
And JavaScript. So someone has put together a JavaScript emulator for the PiDP-11. So
Oh, snap.
even if you don't have
JavaScript.
this here, and you can't physically flip the switches. I'll go ahead and send that link here in Zoom, and if you and Jackie can share it with folks, that would be
I would
lovely.
love that, for sure.
Wonderful.
And
Thank
then
you so much.
the last thing I would love to see is, could I get you to walk out your camera over and give us one nice, good view of that again, that beautiful piece of hardware?
Absolutely.
Nice.
So here I'm just going to walk over here, and here it is running the little LED identification program, and I didn't put the back on it when I moved it. So what I can also do, there it is. That's what the back looks like. You can see the little Raspberry Pi stuck on it. And yeah, and you can see my horrible soldering job, trying to get all the switches to stay down there. So
nice. Wow.
Let's see. So with the rotary dials, we'll show you different, basically different state things. And anyway, if folks are interested, play with that JavaScript version. It requires less soldering skills, and I'll go ahead and send off a link to the place where the kits are available if anyone would like, and some other resources. So thank you everyone for bearing with me today, and computers. So
yes, computers. Thank you so much for joining us and sharing this history and reminding us that at one point we did actually have to think about how large our applications would be, which I find very funny that JavaScript is out there as something you can use with this, because we know how big those can get.
Absolutely. Thanks again. I appreciate it.
Thank you.